and check does it make sense. 19 as opposed to 10. 2 radians. Oh, 5 pi over 8 is the minor arc. Okay, and that's so good that I checked them for making sense. Because look, 5/8 is less than 1. So that means that's a great way to check whether we're ordinary angle or whether we're ordinary or reflex angle. So that calculation is wrong, and what I want. So what you want is the complement, but the complement in terms of a full circle of 5/8 over pi. So what we want is basically 16 pi over 8, which is a full circle, minus 5 pi over 8. So it's 11 pi over 8 is basically the second part of the angle 5 pi over 8. So that 5 pi over 8 belonged down there. Okay. So you can see here of something really important, which is that the common sense test at the end saved my skin, because I knew that 19.6 is only 2 of these, and I knew that 2 radians was less than 180 degrees. So we needed then to come in and just do this calculation again with, instead of 5 here, there's an 11 here. So let's wipe that, because this is what would happen in an exam. You'd have 110 pi over 8. 110 pi fraction bar 8. Okay, and you get 55 pi over 4. And then expand that, and you get a length in centimeters of 43.2 centimeters. Okay, 43.2 centimeters. And that is now the correct answer, as opposed to this 19.6, which was wrong. Okay, that was interesting, and we enjoyed then learning that how to recognize whether it's ordinary or reflex angle. Okay, so on to question 7. So now we will use that knowledge. Here we can see that this is a reflex angle, because we're comparing. Okay, I hope you understand, because this is more than 1 pi, and pi is 180 degrees. So so the angle at the center of a sector is 7 pi over 4. Now we do know that's reflex. That's the major. 7 pi over 4. And the area of the sector is 42 pi centimeters squared. Find the radius. So this is going to help us get our careful thinking going on here. So we think, well, are we working on the top line in radians or the bottom line in degrees? Well, everything is in radians here, so we're talking about the top line. So the top line is telling us that the area is equal to r squared theta over 2. So what we have is, we do have the area, we do have theta, and we're looking for r. So let's get r squared. We know that we'll only take the positive root, because that's the only thing that makes physical sense. So we're talking about double the area over theta. Now this is manipulating formula that you have from your junior cert. And indeed then we could take that further. So let's say that implies that r, sorry I went off screen there, that's terrible, but r equals the square root of 2a over theta.
Is that your fault?
No. Well, it might be upstairs. Okay, so that's all we have to do. So we go to the calculator, the square root fraction bar 42 pi. Now I forgot to double. That's just my area. So I'll double that. You probably want to double that on the fly, as in get it doubled up front and even in your head. Okay, so 84 pi over the theta. Now this is, to be honest, so I could open up a fraction bar here and literally fill in 7 pi, but what I failed to do then is it will work, it'll be right, but I failed to do an awful lot of the arithmetic, the number theory work. Okay, so the answer turns out to be 4 root 3. But I do want to show you how I probably should have done that. So I should have kind of brought it along and see where it goes for me by filling things in and staying in analytical mode rather than computation mode. So 2 times 42 pi is double the area over the angle. And then the angle turns out to be 7 pi over 4. Now, it's a great trick here when you're putting in a fraction in the denominator. It's to basically take the denominator of that denominator and put it up here. So instead of putting the 4 somewhere else, I'm going to pop him back up there. Okay, and then I'm going to cancel my pi's. And I'm going to go, 2 4s is 8, so I'll go 8 times 42 over 7 is what's going to go into my calculator. 7 into 42 is 6. And yes, I could continue on then and take out, yes, there's a 4 common there, but then I'd end up doing the whole thing, and so 6 eighths is 48. Okay, now there's a 16 in there, there's 3 16s in that, so you end up with root 3 and 4, and you could end up doing the whole thing without a calculator, and certainly that's what people would have done in the days pre-calculators, but even now it's still even better sometimes to do it like that. So, but you take your pick on how far you want to take it analytically and when you want to actually go and compute. Okay. So the length of the major arc back there was 43.2 centimeters. And we're on to question 8. So a sector is cut from a circle of radius length 16 centimeters. If the area of the sector, so we got to model this, I don't know what I said there. A sector is cut from a circle of radius length 16 centimeters. So we know the radius is 16 and a center has been cut. The area is, find the angle. So I have no idea how I represent this. Sometimes in an abstract way it doesn't matter whether I get the acute, obtuse, reflex bit right or wrong. So I'm just going to use the generic kind of first quadrant sector, even though it could be well wrong in terms of its scale, but it's still correct to represent it that way. And the square bracket means we're talking about area. So we have 144 pi and we have 16. Now it means a lot more to me than it did in its just written form. So we're to find this angle. Okay, in terms of which formula I should use, well, the angle, this is written, by the way, the radius is common and there's no difference in the radius, but the area is written with a pi in it, so I'm thinking the top, and I could use either, but if I use the top one, I think I'll end up getting, I'll use this one here. A equals r squared theta over 2. So I need theta to be the subject of the formula. So theta is equal to double area over r squared. Okay, so double the area is, I can double that, it's very easy to double that. 288 pi over r squared, which is 16 squared. 256. Yeah, but add 256, we're slightly above a pi, so I should have been down here, but that's okay. So then you just calculate that and you have the answer in radians. Okay, so it's going to be 2, and there's no point in any heroics here because 288, when I say that, I'm not going to bother with the pi because I want that to be part of my answer, so I'm just going to put in the 16 squared there. Okay, and I get 9/8 of a pi, which is 22.5 degrees beyond 180 degrees. So it would be 202.5 degrees. But that's not really important because this is in radians and we prefer that. So that's the angle in radians. That's question 8. So on to question 9. So the diagram below shows a company logo. Okay, so the radius is 5, so I'll mark that in on my diagram. 5 and 5. We don't know this length or this length, and there's no reason to believe they're the same unless they tell us they are, which is unlikely. Okay, because he's hardly straight up, that point could be drifting. So we've 72 degrees at S. Okay, which more importantly makes this 144 degrees here. So find the length of the minor arc in terms of pi. Minor arc? Find minor arc from P to Q. That's this. Okay, from P to Q. So we got 144 degrees and 5. So that's in old money, if you like, for the rate, for the length. Find the length. So we're going to be using this formula down here because we're using degrees. So we're down in degrees, and the left is length and the right is area. So this formula here. So I'll use 2 pi r. And again, remember that's pi r theta over 180 degrees. If you want, for computation purposes, that's the way to go. So pi multiplied by 5 multiplied by 144 degrees over 180 degrees. Okay, out comes the calculator. Now this time I'm going to go shift approximation just to go straight to the answer. Because we don't want it in terms of pi, we want to know how many centimeters it is. Okay. Oh, it does say in terms of pi. Okay, fine. So that means you just leave the pi out, right, for the calculation. Or leave it in and it'll give it to you in terms of pi. So you can't really go wrong there. So if I left it out, I'd be going 5 times 144 over 180. And I get 4. So the answer is 4 pi. But if I left it in, it would still just say 4 pi, and that would be the answer. Now the area of the coloured region in the centre. So it looks like we have a bit of we have to pull up our sleeves here and do a bit of work. So we're going to subtract this area, and this area. That's one way of doing it. Or we can, so we're either working directly or indirectly. We'd probably work directly. So I'm just going to problem solve here and see what I could do with it. I could break it up into 2 separate isosceles triangles. But then I wouldn't know these angles. I can calculate them. Or it looks like I can't because it looks like we don't really care where that is. We know that's 72 degrees, that's all we know. Okay, now oh yes, very important. I just saw it now. Okay, PS is equal to QS, so these are equal to each other. Okay, which means with symmetry we can call this 36 degrees. And that makes this 36 degrees. Okay, and we have 5 here. So probably the simplest, so that both triangles are the exact same, so we're basically doubling up this triangle. Now we have, so let's look at the area of a triangle formula from trig, which is half AB sine of the angle in between them. Now, so basically, and I have, well, to have to, I don't know this side, okay, and I don't want to go off and use the cosine rule to get it, but I have 5 here and 5 here, so I'd like to know the angle in between them. Well, if this is 72, then 36 and 36 is 72, so using the sum of angles is 108 degrees, because of the angles adding up to 180. So then I just use this formula to get the calculation directly. Now it's a half AB sine C, but it's double because we have 2 of them. So let's just say it's AB sine C is the area. And that's 5 times 5 times the sine of 108 degrees. Okay, 25 times 108, sine of 108 degrees. That's the answer. 25 times the sine of 108. Okay, giving us 23.7, the area, 23.77 centimeters squared. Does it make sense? Well, that's 5 is 25. It's in the ballpark. It looks like it's about right. Okay, so 23.77 degrees. And then I think I have 2 questions to go. So question 10, chord of length. So I'm going to leave that and make another video for that.